Eyes on that target, Bob. Tiger 3! Stand by, Mav!
Come on, Bob, come on.
Stand by! I've got it, captured! Target acquired, bombs away.
We've all seen this scene, but why does it happen? Why do the pilots feel like blacking out?
So today, our group will present about a famous movie which is Top Gun Maverick. The first objective of our presentation is to find the total acceleration experienced by the fighter pilot to calculate the overall G-force experienced by the pilot. Then, we will determine whether the pilot could maintain the consciousness at our obtained G-force. For the second objective is the energy consumption. Very simple. We are going to find the total energy and power consumption that is required for the maneuver to fly.
Moving on to the parameters, now to set our assumptions and hence parameters, we first have to analyze the scene from the movie as stated in the introduction. For objective A, we make the assumption that the initial velocity of the fighter jet is 25 meters per second and starts the ascent at an angle of 37 degrees. From there, we can find both the vertical initial velocity, which is 25 meters per second times sine of 37 degrees, and of course the horizontal initial velocity, which is 25 meters per second multiplied by cosine of 37 degrees. We also then make further assumptions regarding the time, t, as 5 seconds, horizontal displacement as 350 meters, and vertical displacement as 1000 meters. A summary of objective A is as follows. Moving on to objective B, we need to assume the mass of the fighter jet and the mass of the pilot. In the movie, the fighter jet is a FA-18EF Super Hornet, which weighs at a whopping 13,852 kilograms, while the mass of an average fighter pilot is at 80 kilograms. This gives us a summation of mass to be 13,932 kilograms. From there, we will be able to find both the responding variables, which are power and kinetic energy.
Let's move on to the calculation. For the first objective, we are going to find the G-force, and in order to do so, we have to find the acceleration. And we are going to use kinematic equation S equal to ut plus half et square to find the acceleration. By substituting all the constant value, we will get Ax is equal to 20 meter per second square, while Ay is equal to 74 meter per second square. Hence, the final acceleration is 76.655 meter per second square. By definition, G-force is the ratio of the total acceleration experienced by a person to the value of gravitational acceleration g, and can be found using formula G-force is equal to A plus G over G. Hence, we are going to substitute the value of A, which is 7.655 meter per second square, into the equation, and we will obtain the value of G-force is equal to 8.81 G. This suggests that Maverick would have experienced 8.81 times the average value of G. For objective B, we are going to calculate the power, and in order to do so, we have to find the work. And to find work, we are going to use work energy theorem. Hence, this suggests that we will have to find the initial and final velocity. And to find the velocity, we are going to use kinematic equation V equal to U plus AP. And by substituting all the constant value, we will get Vy is equal to 255 meter per second, while Vx is equal to 120 meter per second. Hence, the final value of velocity is 281.82 meter per second. But we won't find the initial velocity as we set it as constant earlier. Hence, by using work energy theorem, we will obtain the work done by the fighter jet is equal to 589.903 kJ. And last but not least, for the power, we know that the time is set constant to be 5 seconds. Hence, by using equation P equal to energy over time, we'll get the power is equal to 117.918 kilowatt.
In conclusion, our objectives have been met. We can conclude that for G-force, special forces and pilots are trained with NASA centrifuge training to prepare them for mission. They are able to withstand up until 9G. The 8.81 G obtained is below the survivable limit for trained personnel, meaning Maverick would have been at serious risk of G-lock, which is G-force-induced loss of consciousness. The 8.81 G indicates that Maverick would feel like he weighs 705 kg. The astronaut experiences 3G during rocket launching, while F1 drivers experiences 6.5 G in sharp turns. This means Maverick successfully withstand almost 3 times higher G-force than astronauts and 1.4 times greater than F1 drivers. For energy and power, the calculated value of 117.981 kilowatts is at 99.7% efficiency, which is unrealistic. Efficiency usually drops to 20% in afterburner mode due to increased fuel consumption and heat loss. Jet engines lose energy as heat and aerodynamic drag. The real jet efficiency is at 40%. Our calculation assumes perfect conversion, which is impossible.